Professor to more experience Very Science Lab. Today, possibly one of the longest videos we will ever have done. And so to celebrate, we did it out in the aftermath of a snowstorm. So, today we will be talking about the history of science. This is only part one. So, what are we doing today? Well, we'll start with Aristotle. Physics in the time of Aristotle was very different. Aristotle himself may have been born in Stagira, an ancient city in northern Greece, and his father died as he was young. He went to Plato's academy when he was 20 and left at the age of 37. He had also taught Alexander the Great, the Macedonian conqueror who decimated most of the region between Europe, Asia, and Africa. He had a great empire, but anyway, Aristotle himself, he had many ideas about physics. And so, a few of his ideas were pretty outlandish. Let me tell you about his two main ones. First of all came his 5 elements. His 5 elements consisted of water, fire, earth, air, and ether. All 5 of these elements, there were 4 of them that were earthly and 1 of them divine. As you could guess, the divine one was the ether. And so, this ether permeated all space. And so, it even lasted up until the Michelson-Morley experiment, where its existence was disproven. Now, these 4 other elements had some special properties. While earth and water were meant to go down, air and fire were meant to go up. While water and air were wet, earth and fire were dry or something. And so, he also had some ideas like impetus. The idea that if you take, like a body, like the snowball, for example, and yeet it, then it eventually stops moving because it runs out of impetus. Speaking of throwing, he actually had some ideas about motion. He thought that there was natural motion, like the motion of, who knows, a falling snowball, or rather a snow chunk, or the movement of a thrown snow chunk. Yay! In this case, really the only difference is that an upward and this directional force was applied to the rock as it was falling. And so, he had natural motion and non-natural motion, artificial motion. He had a lot of other ideas too. These were the main though. Now, what came after Aristotle? There were many advancements made by Indian, Chinese, and Muslim scientists. Now, there was this Indian scientist, or this Indian philosopher and scientist named Canada. Not the land up north where everything is snowy, everybody likes maple syrup, and poutine is like everywhere. I'm talking about the Canada with a K. Canada. Now, this was an Indian philosopher, and he may have come up with the idea of atoms. However, we're not sure if they came up with it before Democritus. Regardless, Democritus was still greater. Democritus, he thought that if you take an apple and say sliced it in half, then it would. If you took an apple and sliced it in half, it will eventually you would not be able to slice it anymore. And that tiny little bit you would be left with, that was an atom, as he named it. The smallest possible piece of matter, according to him, the most dense thing ever. And so he was also remarkably close to our modern ideas, considering he was from like 200 BC in Greece, of all places. And you know that Greece is wacky. Still, ancient Greek mythology is wacky. We don't talk about Odysseus, Polyphemus. We don't talk about the Greek gods Athena or Zeus or Medusa or over here. Not in Bari Science Lab. And so, Democritus, what he thought was that human flesh and bones could be found elsewhere in nature, like, for example, a snowball. Okay, never mind. That didn't work. That analogy didn't work. But he thought that elements that made up human flesh and bone could be found elsewhere in nature. And he also thought a lot of other things that were pretty close to our reality. Now, he also thought that there were some properties of the brain he had yet to comprehend that would make it self-aware. And so, all of this made Democritus a pretty great scientist. Now, let's talk about the Muslim Golden Age. Now, the Muslim Golden Age was from the 8th century to the 15th century, or from 700 to about 1400. And so, one of the most revolutionary Muslim scientists was Ibn al-Haytham. Ibn al-Haytham, which I am almost certainly pronouncing wrong, was a Muslim scientist who lived from around 900 to 1000. And what he did was he gave us a pretty good understanding of light. He thought that if you take something like a snow chunk, then light comes to your eye, propagating from every single point on the object, like the snow chunk. And so, this is what gives Ibn al-Haytham a lot of fame. He did a lot of things, like he was the father of the scientific method as well, and he gave us a pretty good understanding of optics for his time. Now, he thought the light came in rays, propagating from every single point on the object. Now, what came after the Muslim Golden Age? Well, let me fast forward approximately 400 years to Nicolaus Copernicus, or Copernicus. I don't know. Any way I pronounce it, it sounds wrong. But Copernicus was the guy who thought of heliocentrism. And now he wasn't the first to think of it. That was Aristotle of Samos. But he was accepted by the scientific community because he had reason to go along with it. He was accepted by the scientists, but, quick plot twist, the Catholic Church was not a scientist. And so, the Catholic Church tried to persecute anybody who listened to this heliocentric theory. They didn't persecute Copernicus himself because they didn't know who he was spreading these anonymous books and pamphlets about heliocentrism. But regardless, they tried to ban these books outright. However, a lot of people started following them anyway. Now, one of them was Giordano Bruno, who not only thought that the Earth revolved around the sun and was not at the center of the universe, but made Earth even less special by saying that Earth was actually just one planet in a universe of billions of planets, and where each star has their own planetary system, quite like ours. Now, the Catholic Church did not like this because, as we said, the Catholic Church not a scientist. And so, what they did was, since they were salty about this, they accused him of multiple weird things, like denying the existence of Saint Mary. And they charged him with formal heresy and had him burned at the stake. He was a martyr for science. And so, another person, so now, the church was really scared of these heliocentric people. Another example of this was the well-known and perhaps more famous than Bruno guy, who was Galileo Galilei. I don't know what those sounds are. Sounds like a frog's not in my mouth anymore. But anyway, Galileo Galilei, he's known for many things, including breaking the link between mass and rate of fall. He also found the acceleration of gravity, the magnitude of gravitational acceleration at the Earth's surface, and much, much more. Now, he was a supporter of heliocentrism. And the Catholic Church, using their heliocentrism supporter detector 4.0, found Galileo being a heliocentrism supporter. And they took him to the Holy Inquisition, and he thankfully wasn't found as a formal heretic, but he was found as a suspected heretic. So instead of being burnt on the stake, his sentence was reduced to house arrest, where he would spend the last 8 years of his life. Now, the year after Galileo died, almost exactly 1 year, it's pretty scary and uncanny, Sir Isaac Newton was born on January 4th, 1643, while Galileo had died January 8th, 1642. Ugh, my God. Anyway, so, now, Galileo had done so many things. What came after him was René Descartes. René Descartes was more of a math guy. He invented the XY plane, what is formally, scientifically called the Cartesian coordinates. And what he also did was, he's the father of analytical geometry. However, he thought that these little metaphysical actions and things he called corpuscles that were dictated by mathematics, he always found use in mathematical explanation, were dictating every single object in the universe, including the snow chunks. But anyway, now we move on to possibly the most revolutionary scientist in all of physics. He was Sir Isaac Newton. Now, this is where we'll end up. Just kidding. I'm not going to leave you on a cliffhanger like that. Sir Isaac Newton was born in Lincolnshire, which is now a northeast county in England. Sir Isaac Newton, as a youngster, he showed signs of intelligence. He was also a very small child and born prematurely. He was described as by many people, including Carl Sagan, as, not being involved with normal human desires, like, we don't mention that on Barry Science Lab, or love, or engagement, or any of that stuff, or crap. That's why he stayed a virgin. And so, he always stayed celibate, and he never married a single person in his life. Although rumor has it that he was engaged to one person. Ooh. Anyway, Sir Isaac Newton, he had so many revolutionary ideas. He discovered that white light, like the light coming from the snow chunks, you see, this is white. So the white light was the combination of all other colors of light. And he also discovered gravity, which was huge. He also invented calculus. However, and he wrote books like Optics, Principia Mathematica, and a bunch of other books that were written in Latin, so I don't understand them. And so, he wrote all of these books. However, his two most important things he did was discover gravity. I was about to say invent, but I realized. Discover gravity, and he also wrote 3 laws of motion that could dictate the motion of anything moving at a moderate speed pretty accurately. Accurate enough for the calculations of the time. And so, all of this caused well, really, a revolution in science. A ripple that's still rippling to this day. And so, is rippling even a word? I have to look through my personal hand dictionary. It's totally a word. And so, anyway, his three laws of motion went as follows. Oh wait, we forgot to mention his equation for the force of gravity. Fg is equal to G, which is the gravitational constant, 6.679 times 10 to the negative 11, times mass 1, which is the mass of the first body, times m2, the mass of the second body, over r, the distance between the centers of the two bodies. And that determines the gravitational attraction between them. And so now there's really a debate going on whether gravity is a force or something like that. But right now, we acknowledge it as one of the four fundamental forces. And so, hibber-gibberish. And so, now what were his three laws of motion? His first law of motion was that an object at rest, like the bunches of snow chunks right over here, and an object at rest will stay at rest unless an external force acts on it moderately enough, like my kick. And an object in motion will stay in motion unless a force is exerted on it. So, for example, if I take another snow chunk, and it will stay in motion once I throw it until it hits this layer of ice or snow. See? It kind of fused with the snow, but anyway, this was the first law of motion. That anything that was at rest would continue to be at rest unless a moderate force was exerted on it. And an object that was in motion would stay in motion unless a moderate force was exerted on it. And so this was called inertia for the resting and momentum for the moving thing. Let me give you a real world example from a weekday. I would always get up with like 5 hours of sleep, really tired and not wanting to get out of bed. I know many of you want to relate to that too. And many of you relate to that as well. I really don't want to get out of my bed when I wake up because it's so comfy. And so, an object that's at rest will stay at rest. And an object that's in motion, like a snow, no. An object that's in motion, like me running to class before the bell, will stay in motion unless a big enough force is exerted on it, like a brick wall. And so, this is a real-world example of the first law of Newton. Anyway, the second law, Newton's second law, states that the force exerted on an object is equal to its mass times the acceleration it has after, or immediately after the force is exerted. And now, that gives us his second law of motion. His third law of motion is that when FAB is equal to minus FBA, basically, let's say I stamp on the snow will exert a force back on me. Equal magnitude, opposite direction. That's what the third law is. So if you punch a wall, then the wall punches you back. Or let me bring you back to the old times, when it wasn't snowing. And my table was sad. The table was sad because a box was sitting on it. And so that means that FAB is equal to minus FBA. So while FG was pressing down on the table, then there had to be an opposite but equal force to hold up the table. And so that came in the normal force. The table was so unhappy that it had to exert the normal force. Anyway, I still haven't pushed that 100 kilo box off it even to this day. I'm sorry, table. But that is his third law of motion. Any force you exert on an object, that object will exert that same force back on you in the opposite direction. And so, those are the 3 laws of motion. Now, thank you everybody for watching. We'll see you. Oh no, I'm not gonna leave you on a cliffhanger. Okay, yeah. Thank you everybody for watching, and we'll see you next time. This is not the full history, as I said. This is only part 1.